1, 2, 3, 1, 2, 3. Okay, let's start. So, hello and welcome to my stream. Today I'm going to show you a little bit about the process of how I'm creating projects and how I'm managing my projects, and let's get right into it. I'm going to tell you what this project will be. It's gonna be a 80 tiny Morse code keyer. You can see the keyer. Here we're just switching to the camera view. Here is the Morse code key that I have. It's just a paddle key. So this would be the bits, the short pulses, and here would be the DAS, the long pulses. We have a 3.5mm audio jack right here, and yeah, I mean, this is basically what we have here. This is all that we have, and yeah, the 3.5mm audio jack goes here into the breadboard, and then we can also see that we have this 80 tiny 3224 chip right here, a buzzer so we can hear the Morse code that we're keying. We have just added a simple like LED on the pin PA2, and it's just going to a resistor to ground. Here we have a FTDI chip. This FTDI chip will be our programmer, and yeah, let's go to the repository view again, and I'm gonna show you what I'm going to create. Okay, so this is basically a 80 tiny Morse code keyer. So a 80 tiny 80 tiny, let me get keyer, 80 tiny keyer Morse code. So a tiny keyer CW. Okay, tiny keyer CW. It's a Morse code keyer using an 80 tiny 3224, and I mean that's basically about it. Let's just create the repository, and now I'm going to clone that. Use now. Okay, so it seems we are having some connectivity issues, which is not all that great. It seems to be doing fine now. Okay, so I'm just going to switch to VS Code now, and yeah, here you can see the little project. Here's the little description in Markdown, which we just wrote, and yeah, so I'm just going to open the platform IO integration in VS Code, and we're going to start by creating a new project, which is the tiny keyer CW, right? So tiny keyer. We are using the Arduino framework, and I'm going to save that into the folder which we have just created. Privacy reasons, you are not going to see anything right now. This is just temporary, and I'm just going to select the project which we have just cloned to our local drive, and now here we're initializing the project now, and well, we basically just have to wait. That's all we're doing now, And yeah, while we're waiting, we can simultaneously look at the Pi MCU proc, which is the uploading method. Yeah, here we just have created the project, and well, it's a blank project. There's not really anything in there at all. So yeah, we're going to start off by deleting one of those things which I automatically set up here. And yeah, I mean, that's all we're doing now. So yeah, this is a very simple thing now, and I'm just going to do a yeah, pin mode. Yeah, now we should know the pins which we are using on the controller, which I hope we can just write PA, like PA2, right? Pin underscore PA2, and it's gonna be a pin of type output. Right, so this just initializes the pins, and yeah, that's about what I'm doing here. Okay, so now we are just gonna do that really quick. So yeah, here is the initialized thing. We just have to reload the IDE again. Just takes a few moments just so things are initialized the right way. Yeah, here we have pin A2. I hope this is what I am actually meaning, or rather what the pin is actually. Okay. Yeah, I don't know if that is good. Okay, so we do have some problems right now, it seems. I don't know if they're fixable or not, but I mean it looks good to look for now. So I'm just going to open the cam view right now. So here is simple, just a simple digital write on the pin PA2. It's actually pin PA2, which is like not good for me. Pin PA2, I think that's what it actually is. So yeah, I had caps lock on. So I'm just gonna write that, and we're gonna write the value high. Then we are going to make a simple delay of like around, let's make it 500 milliseconds long. Okay. Yeah. Then we're going to copy paste that and basically turn the pin off. So we write the pin to like low. Yeah, that's about it. Right. Okay. So now I don't actually know how we're going to upload this, because this is the ATtiny 3224. I mean, I've worked with the chip before, yeah, but that was quite a long time ago. That was quite a long time ago, and so now, yeah, so now this is pretty interesting, because we need like some upload flags, I think, and an upload command, which hopefully works. Okay, so 3224 hopefully works. So we're not going to use PyUPDI, but PyMCU proc. I see. Okay. Network issues right now are not good. Having some network issues right now with the bitrate being probably too high for the stream. So hopefully this can fix it now. I don't actually know anymore. I don't actually know if that has fixed it. I've just turned down the bitrate, and hopefully we're not going to have any network issues from now on. Okay, switching to our thing here. Okay, just in the browser. So PyMCU proc ATtiny, and hopefully we still see how this is working. Oh, this looks great. This is the exact same chip which I'm using, is this FTDI breakout, and yeah, so basically, yeah, I mean, you can see it here on the camera as well. Just switching that on as here. This is the ATtiny, which you can see here, the microcontroller. Here is the UPDI pin, the pin 10 on the chip, or PA0, which is just 3 upwards from here. So pin 3 from the bottom right. And this is PA0. This is the UPDI pin, reset UPDI. Here we have our small 1 kilo ohm resistor, just here, right? And here are the RX and TX pins. Now we're going to connect them here to the board, and just basically do the same as this. Is going to be interesting. Okay, so I'm just going to use this wire right here, and this is going to be connected to the third pin from the bottom. We're going to bend the resistor 90 degrees, both legs, and connect it between RX and TX as shown in the diagram. So between this pin and that pin, right? So here you can see how it is connected between those two pins, between RX and TX pin. And now we need to go from the RX to the UPDI. Okay, so I'm just gonna have to look here. This is pretty tricky as the lettering is not the best, but it is TX here and RX is the blue one. Okay, so RX is the blue one, and we need to connect this to RX, so to the blue part of this. Okay, so we're just gonna do that. and well, hope for the best, I guess. And yeah, let's see if we can upload our sketch. Let's see if we can do that. I'm not that sure if everything works just now. I mean, if it does, it would be great. But then again, if it doesn't, that's not the best. Okay, so here we can see the VS Code window as well. Here are the upload flags, and here are just the PyUPDI and the custom upload command. And I'm just hoping that this works. Yeah, so just gonna upload it now. And yeah, I mean, hope for the best. Yeah, that doesn't sound that great. Yeah, nope. This is not. That's not great. This is. Yeah, I figured this would be happening. I figured, you know, I did. I actually didn't. Like, I was prepared. I wasn't hoping for this to happen. But then again, what can you do, you know? What can you do? So, okay. Well, I figured that might happen. So maybe the pymcuproc command works better. We're just going to go here and hope for the best and just try to upload it, and well, I mean, we do get a different error now. The following arguments are required. I don't know if that's a good word to hear, or required. So yeah, okay, we're switching to the browser. Yeah, okay, so here is the official documentation from the pymcuproc. Here you can install it with the pip installer. Have already done that, you know. And yeah, so these are the commands, and we just want to, yeah, write -f. I think this is what we actually just want to do. So gonna copy that, gonna go to the VS Code again, and just hope for the best, you know, like just write -f and then source. I hope we actually don't need upload flags here as like at all. And yeah, let's upload it again. Let's do it again. Let's do it. Oh, now this is a different problem. This is different. Upload protocol JTAG to UPDI. This is not great. So, yeah, okay, yes. I mean, no, not yes. So, upload protocol. Upload protocol is. Well, I figured that might happen. You know, I figured this will happen. Upload protocol is custom. Do I know? Do I actually know? I actually don't know what the upload protocol is. I mean, it's a custom command, so yeah. Having fun here is what we are having, yeah. And okay, yeah, so basically we want to know the upload protocol platform IO custom command. Yeah. Latest documentation. Okay. Oh, it's just upload protocol custom. Upload flags. We don't have any upload flags right now, and yeah, that's about it. Okay. I mean, that was hopefully a quick fix. Hopefully a very quick fix now. Okay. Upload protocol custom pymco proc write -f source. That's what we're doing. We're doing that. We're doing it. We are doing it. Oh, or not. Unable to connect to USB device. What the hell? What USB device are you even using? Connecting to anything possible. Right. That's great. Like to see anything possible. Right. Not at all. Not liking that. Why would I not? So that would be com5 then, like upload port. Yeah, upload port equals com5. Okay. Upload port would be then like I'm not that sure. I am not that sure if this is so fun. I mean, interesting. I figured we were going to be here not that long. I guess things just take longer than you think, you know? Yeah, that's not great. This is absolutely not great at all. And we have another problem. Why do we have another problem? Something with this. That is somehow a problem here. Okay. Oh great, you don't find anything. Okay. I see where this is going. No, I see where this is going. Okay. I have no idea where this is going. But it's going somewhere. Not where we want it. Not, absolutely not. So, well, 80 tiny, 3224 pi MCU prog. And what do we want? We want upload command. Okay. Right. I mean, I'm just gonna do that. And hope for the best, you know, hope for the best. Oh, what? No. Yeah, no, this is fun. This is fine. Yeah, no. Okay. Okay. I see. This is all good. This is all good. All good. Okay. Right. Okay, those are the new ones. Love to see that. And hopefully like to see upload success. That looks better. How is this? How is it doing that now? What? Okay. I see. Okay, this is, well, it's not an 8 mega, it's an 80 tiny. That's what it is. I see. But this looks promising. This looks promising. Oh, what? Huh? What? Success. We have done it. We uploaded things. We uploaded it. It works. Okay. I mean, it doesn't blink or anything, but it works. Okay. I mean, now we just have to find where like pin 9 is. I have no idea where pin 9 is. But we did just upload something, so that's a huge success. And yeah, so basically we're going to create a commit now, which means first upload working. First upload is working. We're going to upload it to GitHub, and there's that, right? Okay, now we just have to find the pin, and for that I'm going to switch to the full screen camera mode now. And yeah, that's, now we are at the full screen camera, and we are going to see where this pin is. Okay, so what we're doing is using a multimeter on connectivity mode. Just gonna have, yeah, you can barely see it here. Here's the multimeter, and yeah, so here's the multimeter, right, in connectivity mode. So if I connect them together, it makes a small beep. Right, so like this is fine, but actually I've just noticed we do want to have in voltmeter mode, so we read out the voltage that goes outside of this IC. So we're going to have this on the ground right here, and I'm just going to connect it to the VCC line on the other end, and we are writing 3.5 volts, right? So 3.5 volts, which is fine. It is changing on and off, so that means my LED is probably broken. Yeah, but you can clearly see it is blinking. I mean, it goes up in voltage, and then it goes down, and then it goes up, and it goes down again. So this is working, so upload works, and this is great news. However, I may need to get another LED, as this one is not working currently. That's not great, but yeah, some things like that can happen. So yeah, this is fine, you know, this is fine. We've just seen that uploading works, and we can blink an LED without having an LED. Yeah, I mean, we're just turning on and off a pin, and yeah, I mean, that's also very great success. We can see that with the multimeter. I mean, you could just have this on all the time, and you can just look at it blink, or like go up in voltage and go down, and go up and go down again. So yeah, I mean, here we have it. This is it. And yeah, you can see it going up in voltage and going down. So the blink program is uploaded successfully, which is great. And now I just need to get another LED, and I'm gonna be back in a few, yeah, in like a minute. I'm gonna be back. do, 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 do. And he is back. Back again. So, I got the LEDs, and now I'm just going to disconnect the multimeter and turn it off, set it aside. Now, I'm going to get this to pin number 3. 1, 2, 3. So 3 from the top. Third pin from the top, which is actually pin PA2. And well, it's fine to connect this LED directly to 3.3 volts. It doesn't hurt it, and it is designed for that. And yeah, now you can see it is blinking, so it works. Great, it works now. We are blinking an LED, quite bright, but it's working. Blinking an LED. Okay, so that is a great success. Now I do hope that we can also read pins. Yeah, reading pins. So I'm just going to have the dit and da pin at PA4 and PA5, which are here the top two, or maybe PA5 and PA6. I mean, we have enough pins here. I may, however, you know, we are just gonna check that. Okay, alright. So now I'm just gonna do that. Just gonna go here. So this was very helpful. So was the documentation from this one. Yeah, just this great documentation. By the way, great documentation. Can recommend it. So here we are on the microchip 80 tiny family of datasheet. I mean, I've just like printed that out. You can see that on the camera if I switch it again. But we have to do some consideration on what pin we are going to use. We only have a limited amount of pins, and well, what pins we can use is highly dependent on what functions we do want as well. I mean, we don't just want to have the we don't just want to have the LED blinking. We also want to have some inputs. We want to have like the dit and the da as an input. We want to have an analog input as well. So like we gotta know where we have the analog input. I mean, we only have, I think, one analog, like one actual analog ADC, and the other ones are just like switched, you know, so you can only have one simultaneous read of an ADC channel. I mean, there only exists one. Now we are using the SOIC 14 pin package right here, or I mean TSSOP 14 pin. That's the same configuration, right? So what do we want? I mean, PA0 is already like used for UPDI for the uploading. So what do we want as well? We probably do want to have some UART functions. So like PA1 and PA2 should probably not be used for the future sketch. Now we are using this to blink an LED. Just so we know, those are for RX and TX. Okay. Now, oh yeah, no. We have here also two X pin here, which is PB2 and PB3. Okay, yeah, I see. So we need an analog input. We do probably want to have the PB3 and PB2 pins for UART, and we do want to have some I2C, and I2C is on PB0 and PB1. Okay, right. So, going to the camera now, again, right here with our blinking LED. Yep. And I'm just going to, yeah. So, basically, PV0 and PV1 are for I2C, and those are really great because we do probably want to have a display on there someday, not today, but like I do want to have the option to add an I2C display, an OLED LCD, an OLED or an LCD in the future. So those pins should not be used by any other function. So yeah, PV3 and PV2 should also not be used. Like here, PV2 and PV3, those are for UART0. So those are also occupied now. So we only have like PA1, PA2, PA3 and PA4, 5 left. Right? No, we do actually have quite a lot of pins left. That's great. PA1, 2 are also occupied, so basically these are all occupied pins. Yeah, because maybe we do want to have UART1 as well. Or SPI. No, we're not gonna use SPI, so we are pretty open on what we can actually do. Yeah. So ADC 0, right? Made here analog input for that, and yeah, so we're gonna use PA5 and PA6 for the DIT and DA pins, and yeah. So here we have our Morse codes here. Here is the DIT, here are the DAs, so the long pulses, the short pulses, like that, right? And well, here we have the input. I'm just gonna have to beep it out with the multimeter again, so I know where exactly those pins are, right? So here I can see that not that greatly, but yeah, I'm just gonna connect this one here to this pin, and then we're going to go to the second one. Okay, that's fine. Okay, so we're going to disconnect the LED again, and okay, so these are the DAs. Right, and I think one to the left are the DITs. So those are the DAs and these are the DITs. Okay, well, that was quite simple. So now we know where the pins are. And yeah, we're just going to connect that now. Right, okay, so now connecting the pins, so the DIT and DA pins from our thing right here, and the thing is that, yeah, we just have to use some wires here. This is, oh, that's a loose connection right there. That's better. So this is a ground. Or no, actually I don't know if I can do that, you know. So basically we do want to have some pull-up resistors in this thing. I'm just gonna use some 4.7k ohm resistors, as I have them just laying around. Here are some 4.7 kilo ohm resistors, and I'm going to just use two of them as a pull-up resistor for the pins, which means this going to ground is actually quite good. Now we're just going to bend the pins 90 degrees, and yeah, we are going to have this here. Just gonna move this input right there so we can have one power rail. Right, we're connecting a pin here to this rail right here, and now we have the positive power rail here, so we can have our pull-up resistors, and yes, pull-up number 1 and pull-up number 2. Okay, yeah, that didn't work that great, did it? Nope. So, okay, here, pull-up 1, pull-up 2. Now we need two input pins, which we have PA5 and PA6 for that. So I'm gonna use a white wire for the first input, and I'm also going to use a one wire which I can find for the second input. I mean, it's probably gonna be green, being honest. I have a lot of green wires here, which I guess it's light green then. So these are the first ones, these are the second ones. Now we have them as an input pin here on this side right here for the respected pins here. So that's PA5 and PA6 are now used for that. Okay, that is also fine. Fine with me. Yeah, it is fine. So basically we are just going to add the LED back in there, just to have a visual indicator. It's more like a debug LED now than it is anything else at that point. And yeah, I just noticed I haven't connected ground to the ground rail. So yeah, I mean, things won't work when you have. This is not great. That's not good. That's not good. You don't want to have something not working. No. Okay, we're just gonna move the ground here, because we have some problems. Well, yeah, we need another pin now for the ground, and I am pretty limited on the amount of pins that I have left here, but I'm going to use another green pin, right? I mean, that is kind of the ground pin now. Green, right? Typical ground. And yeah, so here is the anode, and it goes to, don't be fooled by that, 1, 2, 3, so this pin right here, going here, and now for linking again. So what if we do that? We go one more, and now we are adding a resistor just to be safe. Okay, now we are blinking. Okay, so the next thing we are going to do is go back to our Visual Studio Code and actually here we are on the Visual Studio Code, and here on the bottom right is just the camera with our little circuitry set up now. yeah, now I will be using something in the future, like I'm going to create nice looking schematics and nice looking diagrams for it. For now I just need to know that PA5 and 6 are inputs, so we are just going to initialize them. So PA5 and 6 are inputs. PA5 is an input, right? So input, this is also an input right here, which is PA6. PA6 is also an input. Now, okay, we are using quite little space, so we can just put them into an integer, right? So we're gonna have an integer, calling that dit, like dit underscore pin, which equals to so dit pin is PA5 apparently now. I think it's PA6 actually, but like, who am I to judge, right? I mean, right, yeah, no, this is totally fine. Yep, right, dit pin, and then we have the dar pin. Oh, didn't want to do that. Didn't want to do that. Dar pin, and then we have the LED. Okay, so the LED pin is here. Then we have the dar pin. The dar pin is PA number 6. And now basically we are going to use those variables now to initialize things, to read things. This makes it way better in future when we actually want to change things and yeah, do stuff like that, right? Okay, so we are going to read the pins now. The pin, the dit pin, we're going to read the dit pin, and we are write to the LED pin, and we're gonna write the LED pin to the value of the read of the dit pin. I mean, this is basically, now we're making a button. Like, this is basically what a button does. Yep. That's everything it does. It's everything that it does. It's not really using all that much space. We've just uploaded it, and it's okay. Well, I don't like that. Oh, no, it's fine. I have just set the LED pin to a wrong value. Oh, terrible, right? Terrible. Which is PA number 2, obviously. So yeah, I mean, those those things can happen, and those are natural, you know. Like, it's normal for you to have like things mixed up. Oh, that's the dar pin. Oh yeah, no, you can see it. Oh yeah, and because we have them pulled up, it reads the pin, and it reads, oh, it's pulled up, so it's the pin state is high, so we're writing the LED to high, which turns on the LED. And when we press now the dar pin, so like the dit pin and the dar pin are just like not right here. The pin is actually PA6 now. and the down pin is PA5. but you can see if I press the button, it turns the LED off, and it's quite fast doing that, right? So that's perfect. That is great, right? Love that. Okay. Yeah, so we can read things now, we can write things, and yeah, now the next best thing is to create a non-blocking version of this with the millis function. So yeah, let's go and write that. We are going to create a variable called the last millis, which is a unsigned long and it's gonna be last millis, and that is going to be equal to last millis is equal to, well, 0, and I mean that's about it. Okay, so last millis, and then we have interval. I mean, we don't have interval now, we just have a last millis, right? So, okay, so now we are going to create we are going to make the LED blink at different frequencies depending on like what pin we're using, right? Depending on if we are making a dit or a da or a dit, right? Different frequencies. So we have to read the pin. We are going to read the pin. Oh, what did I do now? I don't recall doing that. We are going to read the dit pin, and I mean, if we have read the dit pin, something is going to happen. And what is that something? Well, if millis, so the current milliseconds, minus the last milliseconds is greater or equal to, right, which is greater or equal to, greater or equal to, nope, okay, greater or equal to the interval, which we set to 500 milliseconds, right? Then we're going to, oh, I switched my keyboard layout around, that's why it's acting weird. We are going to, we're going to write to the pin. And what are we going to write and to what pin? Well, it's the dit pin, is it? Oh no, it's the LED pin, because we want to change the LED. And it's going to be it's gonna be like that, right? So it's gonna be a it's gonna be a read of the pin that you're writing to, which is the LED pin, and it's actually gonna be the inverse of that. So not the LED pin, which basically just toggles the pin, and yeah, I mean that's all it does. It is toggling the pin And well, toggling the pin is basically what we are wanting to do anyways. So yeah, now it's black. What the hell? Oh yeah, there we go, okay. So yeah, we want to toggle the pin, and hopefully everything will work. And like, I mean, it's crazy, you know, it really is crazy. I mean, like toggling the pin and like I mean like that, toggling the pin like that, you know, it is crazy to do that. But I mean, it's basically what we are doing is just that, you know. So yeah, so this code right here just toggles the pin by reading the pin and writing the inverse of what it read back to it, and that at an interval of 500 milliseconds. And well, not quite, because now we have to say that the last milliseconds are equal to the previous milliseconds, which means we can just equal that to the current milliseconds. Right, so there we go. We just do that, and hopefully that is it. Yes, yeah, I think that's it. Now this is hopefully the non-blocking version of the code. Oh yeah, now we're just going to upload that again and test it out before things happen, before we break everything. I mean, I hope it works. I honestly do. Oh yeah, we still haven't fixed the problem. Okay, so we have like inverted inputs, so things are a little bit weird here. So this is actually the DAW pin, and the DAW pin is 500. Okay, let's make it like 300, and let's make that 100 then. I mean, that's the ratio of DAW pin to dit pin. Okay. We are uploading it. It is done uploading. Okay. Yeah, you can see it. It's working quite well. The DAW pin is definitely way slower than the dit pin is. And yeah, I mean, DAW pin, like now we just need to create more variables, and like we are saving now. We're basically making this dependent on this one. So we call that delay, or like interval, what? Interval time. Oh, nope. And interval time is like 500. Right, so if it's 500, what is the other one? Well, we don't need to know. We just need to know what the ratio between them is. So this one takes interval time, and this one takes interval time divided by 3. That's what it does. That's what it does. Just is the third, like it's 3 times less fast than this one. Or this one is 3 times faster than this one, right? what now? Oh yeah, no, that's what it does. It's just confusing because this is milliseconds. Like yeah, this takes longer milliseconds than this does, because this is a higher frequency than this. So that's basically everything. That's where the confusion is. It's just that this takes like a smaller amount of interval time because the frequency is higher. Right here, these are the dits now, and these are the DAs. You can see it is really like the DAs are just long DAs. Da dit 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 da, right? So that's what it is. I mean, this is working quite well already, and I'm really happy with that. And we're not using, like, we're just using a little bit more than a kilobyte of flash and like 12 bytes of RAM. We have a ton of RAM left, we have tons of flash left. So that is looking great, and we can probably go and like select the version when we only have like 4K bytes of flash. I think this will work in the end, but we're gonna have to see for ourselves. I mean, this works already. Like you could use that. Like you could use that as like a rudimentary, like Morse code keyer kind of thing. Now, I don't actually know, you know. We do probably want to have a library for the buzzer, which I actually don't know how to use the buzzer. Like legitimately, I don't know. Yeah, so I mean, there's that, right? I don't actually know how to use the buzzer, so we are going to have to look it up and see for ourselves. And yeah, let's see. Okay, so we are here now, right? Yeah, you can. Where are we? I don't see my. Okay, I don't see my mouse. Okay, well, this is interesting. Okay, I mean, I could just guess where my mouse is now. This is great. I actually don't see it myself. Well, how great, right? So yeah, we're gonna use buzzer Arduino now. We don't see. Okay, yeah, the buzzer, a piezoelectric buzzer, that's what we have. Oh, come on. Why the hell? What is happening? What's happening? Oh my god. This is insane. Okay, oh yeah. Oh wow, is it actually, oh, it's tone. Right, that's the command. What's tone? It was tone all along. So, I mean, okay. This is an interesting thing, right? Yeah, no, definitely. Okay. Yeah, I mean, oh yeah, now I have my mouse again, which is weird, but something happened. And yeah, so the command is just tone, like it's just built-in function, and I mean LED pin, and then we have the buzzer pin, which, I mean, the LED pin kinda is a buzzer. but we have a separate buzzer pin now as well, which is going to be on pin PA1. Yeah, PA1. As pin PA1 is just one down from PA2. This is going to be the buzzer pin, and yeah, buzzer pin. Now you obviously have to like set the buzzer pin up as well as an output. So buzzer pin as an output, and yeah. Okay. Okay, so we are going to do that now. So tone, right. What pin? Well, the buzzer pin. What frequency? Let's make it 800 Hertz. Duration, infinite. Like, as long as we need to. I don't know. Does that work as well? It does. Somehow it does work like that. Okay. Well, if it does, that's great. I mean, we could make that a variable as well, you know. Tone. I mean, I'm guessing we are going to do no tone here, which is like actually a function. Like no tone is like actually a function. Never mind, it's not called no tone because it is actually called no tone, but with a capital T. So what a difference, right? What a difference. So no tone on the buzzer pin. Yeah, no tone buzzer pin. Okay. I mean, that seems... Code seems to be quite simple. Like, it's super simple code. Like, not even 50 lines of code. And we already have, like, variables all there, and we're not using, okay, 1.5 kilobyte of flash, but that's not a lot, you know, it's not. Does this still work? It seems this does not work anymore, which I don't like it. I don't like it. I feel like we have done a little oopsie now. Which I think it's that the tone library is a blocking library. Now, obviously we don't want to have blocking code in there like at all. Yeah, I mean I could just write my own tone library, or maybe there is a non-blocking version out there somewhere, which is not like huge and doesn't take up like I don't know, 30 kilobytes of flash. We don't have that many. We don't have that much flash. We only have 32 kilobytes, which is not a lot. Like if you know how big a like just a simple like a simple thing could get, like for example your like a small Word file is probably already bigger than 32 kilobyte. I mean, so I mean we do not really have a lot of space here. 32 kilobyte, right? Okay. Now connecting the buzzer, piezoelectric buzzer here to our pin, which is this one right here. Yeah, I think the tone library, it doesn't work with our thingy. It does not work. It's not great. So I don't know. Like a no tone, 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 no tone, tone, no tone, tone. Set the voltage to high to make a noise. Right, yeah. Okay, so I don't know what is happening anymore, which is not good. I'm just going to disconnect it and like reconnect it. Okay, so this is not good at all. Like not good at all. Yeah, so this doesn't work. Well, that is unfortunate, you know. This is actually unfortunate. Tone library. Okay, buzzer pin as an output. We have set the buzzer pin as an output. I mean, you can't really do that much different now. The tone library seems not to work, right? Now, what if... Okay, maybe it does work, but it's not working like we would expect it to work. Okay, I'm just going to have this in the setup. So we're going to tone. We're gonna do a delay of like 500 milliseconds, and then we're gonna do no tone. For the buzzer pin, we're just going to turn off the buzzer pin, and well, hopefully this works. Let's make it 1 second long. We're going to create a 800 Hertz tone. At least that's what I think the tone library would do. Yeah, it says here frequency 800 Hertz. Oh, we just heard it. It was very silent, but we did hear it, right? We did, like you heard that, right? Like it was very silent, very silent. So just gonna like, okay, so disconnecting the power and reconnecting, and you will hear a beep. Or not. Have you heard that? It was very silent. Very silent beep. But it was there. So, okay. This is a very interesting thing. Now the buzzer thing works, right? We know it works, we just heard a little beep. It is just very silent, you know? Let's make it 10 seconds long so you can actually hear it. Listen closely. Oh yeah, it is very, like, it's not that simple. I mean, I'm going to switch to 5 volts now. Okay, so this is that's interesting now. We do want to have the tone though. like we do want to start the tone here, but we also want to stop the tone here, which is not good. You know, we do want to start and stop it here, in this one. So we actually need to, which is not great, but like we need to, we need to create a temporary, or like non-temporary variable, which is just a simple like boolean type variable, and this is going to turn on and off the buzzer. So it's gonna be like buzzer state, right? Buzzer state, and it's going to be 0. Just very simple. We're going to turn off the buzzer, or to make it like easier readable, it is going to be like low or like false. So buzzer state is false. Okay, so this basically is like buzzer state is like, so the buzzer state is equal to not buzzer state, Basically this toggles the buzzer state. What did just happen? And then we want to have this to be the buzzer state, and not like actually dependent on reading the pin as well. But yeah, okay, and as this is a non-blocking code, we're just going to have an if statement here. So if buzzer state is high, then we are going to do a tone for the buzzer pin at a frequency of 1000 forever, and well, else it can only be if or else, so like there's that. So else we are going to have no tone on the buzzer pin. Okay, so here we are, right? The buzzer pin is going to be turned on at a frequency of 1 kilohertz, and then if the buzzer state is off or false, it's gonna turn off the buzzer. Hopefully this works now. I don't know, I have no idea. We're going to try it out and we're gonna find out. Okay, let's upload it again. Let's upload it. Oh, that's not great. That is not great. But maybe that's because we disconnected it and it's now on a different port. Maybe that's why. No, it's not. It's still on port COM5. Well, great. Haha. I'm just gonna force it again. I see. Okay, we will be having problems now with the uploading, which is not great, like at all great. Okay, we're gonna upload it again. switch the board to 3.3 volts, and well, it works now. Yeah, I don't hear anything now. I do not hear anything right now, which makes me think something with the buzzer tone library is blocking, which is not great. You know, it is not great that it is blocking code. But like, what am I? What am I here? Like, I can't do anything now. Okay, I mean, yeah. So again, very interesting, and well, we're going to have to find a different library now for this. I'm just gonna comment the buzzer state code out and just upload it again. I mean, that's all we can do now, is trying it out and seeing if it works, seeing if it doesn't. And well, currently it doesn't. I don't know if you can hear that. Actually, it is very silent. Like, the buzzer is really silent, but you can just maybe make it out. Okay, I see. What if we do that? I mean, we were here before, you know. This doesn't seem to be that great, does it? Oh no, it doesn't. Doesn't seem to be great, does it? No. PA2 is still the pin that we're using for the LED. It's just that somehow it doesn't work now. Or it does. I wouldn't be so sure. I don't actually know what's happening here anymore. Well, I mean, it did work before. Yeah, I mean, it's not great if you have something that worked before and now it suddenly doesn't. So false. I see. I don't see. I actually don't. No. Well, I guess we're going to go to the last version, which worked. Oh, that's not that's not great. Nope, never mind. We are already committed. Okay, we're committed to this thing now. Now we're gonna have to make it work. Okay, so let's see what we're doing now. We are yeah, we're just reading the pin again, so like we did before, and we are just hoping for this to work now. And I mean, what could go wrong? You know, what could go wrong is nothing. Nothing can go wrong. Why would it go wrong? You know, why would you assume it's going wrong? Like, what are you doing? You know, like, what the hell? Yeah, so this actually takes quite a long time, and yeah. I mean, getting to like a prototype is already quite a long thing, and yeah, somehow the LED is not, it's not lighting up again. So I don't actually know where the problem is here. I don't know. So we are going to have to take out the multimeter again and see what the problem was. Yay. Yeah, so multimeter time it is. Here's the multimeter. Right, we are going to have this in like voltage mode, and yeah, now we are going to read out every single voltage which we should have. I'm going to disconnect the LED, or what the... Okay, so it seems the LED has some kind of contact. Like something is happening when the LED is here. It's just not like great. Okay, so what we are doing now is like finding the problems that we have using our trusted multimeter here. Just gonna bring that here in the shot so you see it as well. And yeah, so here's a ground, and here is the LED pin. I kind of have to hold like them. I see things are happening, yet I don't know why. It's not great if you don't know why things are happening. Okay. Okay, not great, not good. And I'm just going to probe now the pins here, which, like, if I change them, they should have something. Like, there should at least be some voltage present there. Right, so from here to the voltage line, it should be 5 volts, or like 3.3 volts. It is not, which, like, that's not good. So wait, is the chip actually, do we just actually not have power? Do we just like not have power now? No, we do have power at the chip. We do have power at the FTDI chip. We somehow don't have power here on the breadboard, which makes me think that this wire right here has some kind of bad contact, right? Like some bad contact. And yeah, so okay, so here we should see, yeah, 3.5 volts as well. And if we trace the red wire, we have 3.5 volts here. Yeah, this is weird. Now we should see 0 volts here, basically. Yes, we should see, like, hold on, this is interesting. Yeah, no, 3.5 volts, and if we push down on one contact, it should not be that. I am very confused now. Very confused. Very confused on what's happening here. And again, I don't know what is happening here. I can only assume things, and well, my assumption is that something does not work. So yeah, here's one of them contacts, and well, we do not see any change in things happening. Yeah, I mean, I'm testing it out with these already. You know, like it is not that. Yeah, this could be a bad contact here, could be bad contact there, could be that, could be this, could be everything. Yet we do not know what it is. Or why it is. Okay, change of plans. We are going to use like two buttons, or like two wires that act as buttons. And yeah, I mean that's about it. Like, change of plans, we're just gonna use wires as buttons now. So yeah, they act as our dit and da button, and that's what they're doing. It's nothing else. They're just acting like they are those buttons. We're using them now as a button, and that should work now. That should just work, you know. And here we have this thing again, going from this LED pin to ground. LED pin to ground. That is a crazy thing, but it is here. Okay, I see nothing has changed, which makes me kinda concerned about the code not working. I'm quite concerned about it. Why doesn't it work? Why doesn't it work? I don't know. And it is kinda weird. To ground? Oh no, I don't like that. I don't like where that is going. Like I don't like it at all. Oh no. This sounds very sketchy. Why does it even sound at all? It's an LED. It shouldn't do that. I am concerned about my things not working right now, and well, let's fix it with another green cable. I don't know why I have tons of green cables. I guess I haven't used them for a while. I'm just hoping that I don't have any bad contacts now, which could do something that would hurt our chip. Okay, voltage on the chip is fine. This is a fine. Right. So here we have this pin, which now okay. Yeah, this it's blinking again. Yeah, you can't even see it, but it is blinking now, and yeah. No, it's not. And now it is. This is not great. This isn't good. It shouldn't it should not do whatever it's doing now. We do have like lots of bad contacts. Like lots of bad contacts here, and yes, this is not great at all. Like there's a lot of bad contacts. At least this works still with the frequency changing, but like you actually can't be sure now. Yeah, now we have with this thing being a problem again. So yeah, this is not looking good. Okay, it is blinking, so I guess at least that works now. The buzzer doesn't work for some reason, so we're just gonna try to get that working as soon as possible. And yeah, I mean, maybe the buzzer state actually works. I would still be concerned about it, you know. I mean, if we put it here and it works, then that's great. If it doesn't, and it like just doesn't work basically, then we have set up things like incorrectly. But yeah, now we've uploaded the new sketch. No, this works. This is fine. Okay, so it works. Oh my god, these cables are not great. Gonna have to buy some new cables, definitely. And yeah, cause those cables, like they don't work. You can't work with cables which just have bad contacts all the time. Like that is just not something that would work. Okay, so we're adding the button state thingy again. Now with both dit and da being with the button state. Oh no, I have forgotten to do that on the da side as well now. So yep, just gonna have to upload it again. Oh yeah, we're only using like 3.3% of flash, and yeah, that's so little. And like 0.4% of RAM, like 12 bytes. Like that's equivalent to you writing like 12 letters. Oh, sorry, 13 bytes. So 13 letters, 13 characters, like in a plain text file, right? So that's what that is equivalent to. That's nothing. But we can see that it works now with the long pulses and with the short fast pulses. This is now with the button state thing already. So yeah, what I'm gonna do is I'm going to make a commit, like a git commit again. Here you can see everything that changed, and I mean, yeah, that's quite a lot. And well, this is the first like like a non-locking code different frequency blinking. We're going to sync it, we're going to create a commit, like every time when you have something done and tested or not tested and you just want to have it online or on your Git repository, you just create a new commit, because now, like, I know this works, I've tested this. If I somehow like do something completely stupid and it doesn't work next time, I can just go back to this commit and everything will work again. Like, that's why Git is such a huge and powerful tool. And I'm going to make a video on how you can use like basic commands of Git, how you can use like platform IO for your things and all of that. And yeah, so there's that, right? There's that. And yeah, so basically we're adding the button state thingy in there again, and we're uploading it, seeing if it works. If you hear something, it works. And the buzzer is very, very like silent if it would work. Okay, so I have just I've just put the microphone next to the buzzer, right? I don't think I hear anything, do I? I mean, it blinks, but it doesn't like it doesn't sum. I don't like the sound of that. I think I'm just gonna like do like the buzzer thingy again with a millis example. I mean, it's just basic PWM, you know. So I mean, that's about it. That's what it does. So okay, buzzer somehow doesn't work for some reason. This doesn't work. I mean, it should work. And yeah, okay. So basically we are going to put those together and create two more variables for our like interval time is like 1 millisecond, 1 kilohertz. So last millis is 0, but this is now called last millis for last millis, like buzz, and interval time for like the buzzer as well. So interval time is 1 millisecond. That means the frequency is 1 kilohertz, right? 1000 pulses per second. That's what it is. Hopefully. Well, I mean, it may not be. It may not be though. Now we're just going to basically copy paste this from the command from here and just make it this last millis and like last millis buzzer and interval time buzzer and and then, well, we're not going to change the state, but oh no, we are going to change the state of the buzzer, but we have to create a new variable for that, and we are going to write to the buzzer pin now at a frequency of 1 kilohertz. So that's what this does. So this is buzzer state. Also this is called now buzzer last millis buzzer. So yeah, this is all of this is the buzzer code. This is all buzzer, and buzzer state is now also wrong as we do. I'm just going to put the buzzer state up here and like create a new variable which I call how do I call that? Buzzers. I mean, it is buzzer state. It's just buzzer state buzz. Buzzer state frequency? No, buzzers. What is that? PWM? I don't know, buzzer state PWM it is. Okay. May not be the best variable name. May not be the best variable name, is it? But I'm hoping it works. Okay. Right, uploading it. Yeah, I mean... Yeah, no... yeah, it works! It works, it works, it works, it works. I don't know why the tone library doesn't work, but this works. This is great. This is really great. This is... Oh yeah. So the LED is blinking at an interval of like 500 milliseconds now, but like the LED blinking changes the buzzer state here, which then like does everything here, which changes the buzzer PWM state, which changes 1,000 times a second, or at 1 kilohertz, which the interval is obviously then 1 millisecond, as the frequency is calculated by that. Yeah, so it's oh, this is great. This is really great. Yeah, this gives me lots of more energy now. Oh yeah, yeah. This is great. Okay, I see. No, it works. Oh yeah, no, this ground cable has like a has bad connection as well. You guessed it was because like the because of like some environmental things that were happening with those wires as well. So I need to get some new wires definitely. Yeah, this is not great. Like you can't work with wires that are just bad. And yeah, here's the fast one. You can definitely hear that. Okay, so yeah, I mean turning it off again is kind of difficult. But we do have a buzzer that is buzzing at 2 different frequencies. I mean, it's still buzzing, like both are buzzing at 1 kilohertz. It's just that one is buzzing faster and one is buzzing like not as fast, right? So basically, one is buzzing at like an interval of 500 milliseconds, and one is buzzing at an interval of 500 divided by 3 milliseconds. Like, because the da sound for Morse code is 3 times the time it takes for a dit. A dit just takes 1 time interval, and a da takes 3 time intervals. And now this is not that, like, this is a very, very simple thing. It is like this is the most like simple thing you can do. Now I do want to change the frequency and not to change the buzzer interval time. Like, I could make this like variable between like 1 and like, it's like the thing is with millis you only have like milliseconds, right? Milliseconds. So like you either have 1, like I can only have like 1 milliseconds of thing, or like 2, nothing in between, and 2 is like already half the frequency. Let's just try it out. I'm gonna show you. Okay, I'm just gonna show you how that would sound. I mean, now the frequency is definitely completely different. So yeah, you heard the frequency before. It was quite the high-pitched sound. Oh yeah, loved it. And now you hear the frequency being very, very like low. It's like 500 hertz, you know, 500 hertz frequency, and before it was like 1 kilohertz. So next thing is we do want to change the frequency and not the interval time. And we do want to have the interval time in microseconds and not in milliseconds, because milliseconds only like gives us those two, basically those two things, like 500 hertz or 1 kilohertz, right? So that's what that does. So we're going to use micros now, which is like microseconds. And obviously what? No, I wanted to copy it, not paste. So we, last millis. Okay. Oh no, this is, oh no, I changed the wrong code. No. This is not great. There we wanted to change the buzzer state code. Right down here. The buzzer state code is responsible, like this is for the frequency here. Like this just says when the buzzer needs to be on or off, and here we are like basically a very rudimentary PWM thing where it's a duty cycle of 50%, as 50% of the time it's on, 50% of the time it's off, right? And at what frequency? At the frequency which we are going to set here on the top, right? So basically here we have to set the microseconds. Now obviously last millis bus is kinda like not right because it's micros. So micros, right? So last micros bus, obviously it's not milliseconds now, it's microseconds now. So interval time bus would then be like 1000, or again 1 millisecond, 1000 microseconds, 1 millisecond. That's just simple math, right? And yeah, so hopefully this still works like it should have been. Yep, it is. I don't know if you can actually see that, but yeah, so it's definitely beeping. No, okay, great. No. Yep, it's beeping. It's working. This is fine. This is fire. So now we just have to create a simple like calculation here in the setup where we can set the interval time bus by a variable. Okay, so default would be 1000 microseconds now, but we do want to set the frequency obviously in hertz or in like kilohertz. Now let's make it in hertz. So this would be buzzer frequency. So let's call it frequency buzzer. Frequency. Let's make it a short one. Frequency buzz. So this is the frequency of the buzzer. And let's set it to 1. Let's make it fun. Let's set it to 700. Yeah, because this is now 700 hertz is a frequency which we would have not achieved with the code as it was written before, and can only achieve by using the micros function here instead of the millis function, as now we have way higher resolution. In fact, like we have a 1000 times better resolution with micros than with millis. Pretty simple. 1000 microseconds are 1 millisecond, right? Before we could change between 1 millisecond or 2 milliseconds, which would be 1000 microseconds or 2000 microseconds. But now we can change between 1000, 1001, 1002, 1003, so on, and up to like 2000, 3000 obviously microseconds, that is, right? So we just have we just have 1000 times better resolution now. So now we need to go from the frequency to the interval time, right? So we want to set the interval time for the buzzer, interval time buzzer, to be right? Okay, so 700 hertz is like, yeah. So 700 hertz, what is that in milliseconds? Well, 1 kilohertz is what in milliseconds? Well, 1000 hertz divided by 1000 is 1 millisecond. What? What now? What did I just calculate now? What? No, it's 1000 hertz divided by 1. No, it's 1 over. It's 1 divided by 1000 is a thousandth of a second. That times 1000 is 1 millisecond. Times 1000 again is a 1000 microseconds, right? Yeah, so 1 divided by frequency, so 700, is like 1.428 something milliseconds. So those 0.001428 something milliseconds by times 1,000,000, so 1 million, and that gives us the microseconds. Okay, so in code that looks like follows. In code that would be then like 1 divided by the frequency of the buzzer, right? And that times 1,000,000, which is 1 million. So that's how you calculate the time if you have a given frequency. Now that is time in microseconds. Now if you weren't to calculate it times a million, then you would have the time in seconds. If you times it by only 1000, you would have the times in milliseconds. Got it? Okay. So let's upload that again, and now we should hear the 700 hertz and not the 1 kilohertz, right? So a little bit of a lower tone, not higher but lower, right? We're just uploading it again, and now I'm oh yeah, you can maybe barely hear it. It is very, very silent. I'm just gonna put it right in front of the microphone now. Like, yeah, it's very, very silent. So this is the fast one. Right? And now the small one. Like this is the long one. But you can hear the frequency being different now. Okay, here you can see it in the on the image here as well. Right. So it's very silent. It's very silent at that frequency. So, but like you can change the frequency now. I mean, probably with a higher input voltage. I mean, the input voltage on this one and the current being drawn from a single pin and not through a transistor, like that makes this very silent, you know? Like it's running on 3.5 volts, almost 3.3 volts. It's not that loud. Like you can barely hear it. I can barely hear it, you know? So let's change the frequency here to like 1500 and upload it again and see what's happening. Frequency should be way higher, more than twice as much. We're just uploading it. I don't actually know. I don't know what it did. Okay. I don't think it goes that high of a frequency. 100 Hertz. Very low. Let's try that out. I don't think the buzzer will like 100 Hertz. I don't think you will be. No, we still hear the same thing. Which makes me think something is wrong. Yeah, this is not good. Okay, kilohertz. Uploading it again and okay. Yeah, no, I don't like the sound of that. Like, literally, I don't like the sound of it. Because it sounds like there's no difference. Which is not... It's not what we wanted. Okay. So what's happening now? What's happening now is... Yeah, no, that's how it should sound, you know? Oh, it's way louder now. It is way louder now. So definitely something to do with that. Like something to do with that. Just be silent now. Just be silent. Now it's actually annoyingly loud. So that's also again very good, very nice. I mean, like if I want now 700 Hertz of a frequency, I need to have, I need to divide 1 divided by 700, which gives us the time in seconds, right? And then we multiply it by a million, which gives us 1428. So 1428 is now this thing. 1428. Like this is 700 Hertz now. Should be lower than it was before. Like, obviously. But we do not want to calculate that in a calculator. We want to have the code automatically know that this is the right time. Yeah, now it works. Now it works. It's just that it also doesn't. It also doesn't work. And that is not great. Right, this is not great. We do want to calculate the interval time buzzer by like this thing, which should work. Which, I mean, this is the exact same formula which I am using in the calculator as well. Now, maybe not. Maybe not. Maybe this is like stupid or something. Like, this is what I'm using. I may know what the problem is. I may know what the problem is. because I think the controller is only calculating it as a integer, which would explain why it doesn't change the frequency. Now, obviously this is a float at that point, you know? Like at that point it is a floating point number after it's calculated, and we are just calculating using floating point numbers, which takes the microcontroller quite a long time, and I hope it's not a big problem, but 1, 1, 2, 3, 1, 2, 3, so 1 million. 1 million, and yeah, I think it's because the controller is calculating it as an integer, and if you divide 1 over something using an integer, you just get like basically an error or an overflow or like 0, right? So it's not good. It's not good. We want to calculate it as a floating point number. Okay. Yeah, so this works now. So this works now. Okay. Okay. Annoying sound. But like maybe 500 isn't as annoying. You know, it should be lower frequency, it should work, and yeah, if we hear it, all right, all right, we hear it. It works. It's good. We can now change the frequency here, and it's automatically getting calculated here. So that is perfect. Love that. Yeah. Okay. That's great. So I'm just gonna like take a quick break, and I'm gonna be right back. Okay, so as you can clearly see and hear now, it works, and it's like really annoying. So I'm actually just going to like put that thing away. Yeah, we still have that problem where it just keeps on, but we do have a longer and a shorter one, which is quite good, which is really good, honestly. And we can change the frequency here, and everything is fine. So again, going to make a commit. And what did we change? Well, frequency. What do you mean? What do you mean? Frequency. Frequency is now configurably configurable. Frequency is configurable. Terrible word. I can't say it. I can't pronounce it. Yeah, mispronouncing it every time. Yeah. Frequency configurability. Yeah, working. It's working now. Yep. And again, using Git is a powerful tool, and we can always just like move to the first commit, or like to the first ever version, and you can just see what changed, what didn't change, you know. And this is nice, you know. Git is a nice version control system. I use it basically all the time, and yeah, but like it's really great. It's really nice. Now we have to work on this system right here. I mean, it can't be that we just do that and that works. Now what I do know is that basically Morse code can be presented like Morse code. I can just tell you, like Morse code could just be represented using ones and zeros. So I could do that, right? I could write some kind of like byte which just saves all the things and does it like that. Yet I don't know if that's the best thing. I think for a user it would be better if it was an array of numbers. Then again, I don't know how the controller would interpret an array of just simple bits, like simple boolean values, if it just like if it is an actual like boolean value, or if it's then just allocating like for every single space like a whole byte of memory. I don't know. I mean, if it's good, it only allocates like 1 bit per like bit in there. If it's not good, it's well, we're gonna see. So yeah. Well, Morse code. Let's say we have some input. We have like didade, right? Did. So a 1 is high, right? Then we have 1 like 1 0 again. Did. Da. Did. And then we could so didadi, da dida, da, did, da. So this would be then didade, da dida, right? This is just simple ones and zeros, just simple binary, and well, didadi, da dida. That's what it is. And yeah, so Morse code can be represented using this, and it's quite nice, and I love it. But I think I'm good. Like, yeah, I'm gonna just create a not create a byte, but I need some kind of buffer, like an input buffer, because otherwise like this would not work. So I need like a rolling input buffer, you know. So this is also just a boolean variable, but it's actually a boolean array, and I'm calling the array input buffer. Input buffer. So input buffer is an array. It is a like 2-byte array, and we initialize it as all 0, so it's initialized. So okay, great. Now here input buffer, and then we can like write zeros and ones in the input buffer, and then here the things will just get read from the input, like a 0 will be read, so we have no tone. A 1 will be read, so we have a tone. So this, like, it reads it and saves it to the button state, buzzer state, and then like it beeps, right? So if it reaches 0, okay, let's just use this as an example as well. So now we are reading the 0, and so we do nothing. We do nothing. We turn it off, like buzzer stated off, 0. Then we have a 1. No, we have again a 0. So buzzer is off. And you can see every time like we read 1, then we basically say, okay, this thing here is now the value of this thing, so it's a 1. And we basically do that for all things, so we shift it 1 to the left. 1 to the left, now we read a 1, okay, 1, this means that we are executing this thing right here, which creates a tone. Then we're moving on, and we're reading a 0 again, we're reading a 1, and so on and so on. But we're also only reading the first thing, and then we're shifting everything to the left. Like now we would read a 0, we delete it, we shift everything to the left. We're reading a 1, delete it, shift it to the left. I think you get it, right? So that's what the input buffer is for. And yeah, that's what I'm gonna use it. And I mean, you're just here with me, and we're gonna see if it works. If it doesn't, well, it doesn't, and we have to just like do it again, you know. Okay, so now like the last sketch used 24 bytes. Now this would be 2 bytes, like 16-bit is 2 bytes, as a byte is just 8 bits. So if this is a good compiler, and like it knows that Boolean is only 1 and 0, and it allocates the right amount of memory, we should see this very only increase to 26 bytes of RAM. Hopefully it does that. If it does, we have way more space, and now I'm actually concerned because it didn't go up. But maybe that's because we only initialized it and we didn't use it. Now what if we fill up this, what if we just fill this up, like with our example again. So that would be 0, 0, where's 0, 0, 0, 1, 0, 1, 1, 1, so that's star. Then there's again a thing where you have 1 amount of space, and then we have a dit, then we have space left again. So oh yeah, these are Boolean variables. Oh, we forgot the equal sign. Okay, right, I see. What if we just don't do that? I mean, it's not gonna work with it. Nope, it won't. We know, I know it won't work like that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces now. 11. So did 13. 14, 15, 16. So that would be the example from here, and yeah, we hope, or like I hope this like hopefully changes things here, like from 24 to 26 bytes. No, it doesn't. Well, I mean, also okay, because we don't use input buffer anywhere in the code. So that is also fine. Like honestly, it's fine. This is better than I thought. That's a like if we don't use it in the code itself, then it can't do anything with like the variables, right? So it's just ignoring it, which is like super huge. Like ignoring the values is so huge, and I think it's really good that it does that. Now, again, I don't know if it actually is that great. I mean, yeah, I don't know actually. And I mean, if now I'm just gonna fix that small issue that we had before, where we just make the we just write to the buzzer pin again, and yeah, we just set it to low if it's not used, right? So we're just doing that now. So if like the buzzer state is false, then we write to the buzzer pin the value low, so we deactivate it. Got it. Okay, great. So now we actually want to change the buzzer state, but not according to the LED state. Or we could do that. We could do that as well. Just different. Okay, so I think that is the simplest thing, as we just. Okay, so what do? We say input buffer at where? At 15. No, 15. Like at the 15th thing is equal to 1. Right. So this says that the last index of the input buffer will be set to 1. Right, but before we do that, we need to shift. We need to shift the buffer, and this is now a function which we need to write, which is the shift buffer function, and we need to initialize up here the shift buffer function again. Right, so function is initialized here with a void as an output type, so basically no output, and here is our shift function. Okay, so this is just shifting the buffer now, shifting the buffer, right? So okay, basically we need to shift everything like this. The 15th place needs to be shifted to the 14th. The 14th needs to be shifted to the 13th. So basically we are creating a loop. We are looping through the like smaller than 16, right? And we increment I every time. So basically what we want to say is that the variable, which is called input buffer, so input buffer at the place of I is now equal to the input buffer at I plus 1. I plus 1. Will that work? Is the question. Okay, so let's say we have, let's say we make it like, we make this variable right here. Now we are just going through the code in my head basically. So the input buffer at 0 is 1, is now equal to the input buffer of this variable plus 1. So 0. Now this is it, we're looping in. Now I gets incremented by 1. So now I is 1, right? So this is 0 and now this is the space 1. Space 1. So we say, okay, input buffer at 1 is equal to this thing plus 1, which is 1. Okay. So like everything here works, right? It works fine. It gets to 15. So 15. And this is now going to be the state of 16. 16 we don't have. We don't have 16. Right? Let's make it like that. Okay, so let's say this is the 15th space in our 16 space array. So this is 15th thing, right? So now it like the last two are like 1 1 0, right? It's like we have 1 1. We're now here. We are now here at this thing right here. We are, so here everything works. Here everything works. I is like 14, the next one is 15. 15 is a 0. We write that down. We loop again. Now I is 15. If I is 15, right, the 0, I plus 1 is indexed out of bounds. Like 16 doesn't exist. That's the problem. I plus 1 doesn't exist if I is 15. Because then, like, input buffer at 16 would be, like, the thing, which we don't have. Now what if we're going to, like, make it less than 15 here, so the last one is, like, 14. 14. And the next one is then 15. What? Or probably what I'm just gonna do is like just gonna create an if, and if I like equals like 15, if I equals 15, input buffer at input buffer at I like input buffer at I equals to, well, what do we say? I mean, this is obviously the else condition. This is the else. This is the normal thing, right? We do that else. So if I equals 15, buffer at 15 equals buffer at, no, buffer at 16 doesn't exist. So buffer at 15 equals 0. Yep, we just like say it's 0. Like that's it. And anywhere else, like if I is 14, 14 works, and then there's 15. This is fine. Like I plus 1 would be then 15, so 15 works. This is fine. So what this does is basically it just adds an extra 0 at the end. This is everything it does. Like the output would be like this, right? If the input is this, the output would be this, and this is just the 0 which we add at this state right here. So I mean, it's just like a simple else right here, right? Simple else, and we so basically we are doing this one every time, and only if it's 15, which is right on the edge, it just adds another 0 at the end. So that's what shift buffer does. So yeah, now we can shift buffers. Great, right? And now we just say, okay, instead of like the 15th space being 0, now we just set it to 1. That's basically what that does. Go shift buffer, we add a 1, we shift the buffer, we shift buffer again, and we add a 0. And we add a 0. Right. Yeah, we could just not do that, because it already does it in the shift buffer code. However, like that, it's just easier readable, right? It's just way easier readable like this, and I mean that's like everything it does, and this is great, and this is fun, and this is fire, and yeah. So basically everything works fine now, and for a dit, right here we have the dit. So this is the dit code, the dit code. So 1 0 something, you know, it would be like something something 1 0 something something, right? Then we have the dar code, like right here. The dar code, the dar code, which is something something 1 1 1 0 something something, right? This is the only difference. So I mean, we're just going to like copy it from here, paste it there, and then we just copy this one like twice, paste, and so now we add 1 1 1 0. Now, yeah, we could just shift buffer and that error automatically it's a 0, but like that is just easier readable. Basically, this makes it more human readable. Okay, now this is what we do, right? We added that. I mean, everything before like is just zeros. That's everything it is, right? Okay, so now button state. So we want a function which changes our button state now, or we create another variable, which maybe this is not, oh sorry, buzzer state, right? If we create now another variable which is not called buzzer state, but like not buzzer state, then everything is probably going to be fine and work still like great, like, right? Yeah. And honestly, like this, I'm pretty certain that this will work, right? I'm pretty certain that this will work. Now we just have to create a reader which reads the input buffer and shifts it, right? So this is the writer. This writes to the buffer. This just writes to the buffer another thing and shifts the buffer, right? Yeah, no, that's what it does. Now I'm not so sure if it should do that, however. Oh yeah, no, I'm actually not sure if it should. I don't know if it should like shift the buffer. Okay, we do have some, like now I'm no things, like we need to make a buffer reader. Huh, sounds familiar. Sounds familiar to school when you need a buffered reader and a buffered writer for inputs, and I mean this is basically what we're doing right now, just like way simpler and like with way less available space and used space. Ah, we're over 1,000 bytes now. Still under 4,000 bytes, which is insane. Yeah. Basically what we need to do is we need to read a buffer. So it's like input buffer at 0, right? This is where the read head is right now. Okay, so we read basically the buffer, then we shift the buffer again, and yeah, so we read and we shift. We read the buffer and we shift the buffer. Now reading has to be faster than writing. Or can writing actually be... no. Yeah, let's just do that and see if it works, honestly, man. I mean, buzzer state would then be input buffer at 0, right? Let's not make it like that. Let's create a buffer state variable. So it's gonna be just a boolean, like buzzer state, and then we have buffer state. So yeah, buffer state instead of buzzer state. So buffer state, and then we have buffer state, which then equals to our input buffer at this specific place in memory, which is where the read head is. It's always at 0. Then we shift it again, and then we read it again, right? Now reading speed is also at dit speed. Is it? Is it at dit speed? Yes, it is at the dit speed. Yes. Okay. So right, we're doing it. Okay. So at the dit speed, we are reading the buffer, and we read the buffer and store it into the buffer state. Then we yeah, this has to be buffer state now, right? But buzzer pin, but buffer state. Now this just says that buffer state is equal to that, and then we just shift the memory, right? I see. How should that work? I don't know. I mean, okay, I mean, it should just read it, write it to the buffer state, shift the buffer 1 over, and then we can write stuff in there again. I mean, it's doing that all the time, and so it's shifting the buffer to the left all the time, and we're inputting things on the right and shifting it then again, right? So we write to it and we shift. Now I don't think that the writing is going to work like that. I'm not having super high hopes for this, right? Yeah, so this may not work. However, let's just test it out and see what's happening, right? I mean, what's the worst that could happen, right? So we have just done the uploading, and let's see. This is yeah, I am I don't think this is I don't think that's great. I don't think this is good. I'm going to remove the LED indicator from here and move the LED indicator to here. Oh no, we could actually just do it like this. Diff the LED at the buffer state, right? Right. Okay, so now we move the indicator LED to indicate the buffer state. I mean, we could like, this is really loud. We could use like UART for that, but UART takes quite a lot of. Okay. Yeah, so it just. Oh yeah, no, we love. Oh yeah. I see. This is this is interesting. Yeah, no. I. Yeah. Okay. Well, I guess it. I guess it does something. Yeah. Yeah, this is not great. This is really not all that great. So let's just simplify this a ton by basically just removing a lot. Like a lot. We are removing a lot of code and testing it again and again and again and hoping that it works. Right. Okay. So the buffer state is always red here and then shifted. Right. Maybe we actually need 3 input buffers. Oh, and it didn't do that. Okay. Well, it's not that bad anyways. It's not too bad, and yeah, now we have some problems. As this function moves the buffer as well, and that could be not good. May not be that all that great, right? Let's just make it super simple and just for both dit and star do the same thing for once here. And we're just going to shift the buffer, we're going to input something, and the rest is handled by this. So yeah, that's about what we're doing here. And I mean, if it works, it works. If it doesn't, it doesn't. Again, it's pretty simple, you know. We have uploaded it, and we are I am yeah, I mean it's loud. It does something. It's quite loud. It's super loud and it is really hurting my ears. We're uploading it, and we hear nothing. Okay. It's also an interesting approach. Okay, so this is somehow not really working. Okay, so we need to shift in a 1, like a 1 1. Like we shift in a 1. Right. So this happens every time we have this thing. We read the buffer and we wait. And we shift it, right? We read the buffer and wait. Okay, so we read the buffer, we shift 1, then if this is the case, right? We need to integrate this now into that function as well. So if this thing is the case, then we are going to do the lit code, and if it's this one, we do the dark code, right? And now I just integrate that into this thing as well. Like, it's gonna be very simple thing to do, to integrate it into like everything and just basically have it working like that. And yeah, I mean, I don't know how to do the dark code. I mean, like, it does take 3 times as long, right? It does. And yeah. Do we actually need the buffer, the buzzer state? What does it even do? Oh, it doesn't do. Oh, it doesn't do anything now. Yeah, so buzzer state is just not needed anymore. Because now we have the buffer state. So buzzer state got, it's now buzzer state. Oh, I don't. Interesting. Yeah. So. Oh no! This is the millis. It's everything is fine. Everything is fine. Yeah. I didn't do the last millis, did I? Yep. No. I didn't. I didn't. Okay. That's also fine. And like, being honest, this is about to work pretty well, I would say. Now I'm removing all of that code. We don't need it anymore. We have only one. Like, this is basically, this is a read head, right? This is the read head. The buffer state is the read head. We read the buffer every time at the index 0. Then we shift the buffer 1 to the left. Right? So we read it, we shift it, then we input it. Then we like here we input the dits, here we input the dars. And then we read the buffer again. Right? So, okay, so we like write to the buffer. So, yeah, how was the buffer called? Input buffer, yeah. So, input buffer at like the last index, which is 15. And we are going to equal that to a 1, right? So we add a 1, then we shift the buffer like 1 more, and then we write a 0, right? So we write a 1, we write a 0. And then we shift it. Do we shift it again? Do we though? Do we shift it again? I'm not sure. Actually, I have no idea if we shift the buffer again now, or if we actually shouldn't. But the dark code is like copy paste the did code except we have like not 1 1 but like 3 1s. So I mean that's it. 1 2 3 1s and a 0, 1 1 and then a 0, and I mean yeah, hoping it works. That's what everything is. Right. That's everything there is. We're using 40 bytes of RAM, which is like fine. 1000, not even 1500 kilobytes, 1.5 kilobytes of like RAM. Oh yeah, now it. Why is this sounding so terrible? Oh yeah, now I know why. I know why it's sounding. This is not. This is not like great, is it? Oh yeah, no, it's not. Interesting. Yeah, I would like to see what's happening with this IC. I would really like to see what's happening here. Yet I don't. Yeah, I don't see anything. And yeah, this is not the best kind of thing. You know, this is not super great right now. Yeah, no, it's not. And like basically we have no idea what happens. And I mean, like why is it when I like move them around, things happen? That's not super, like that's not the amount of like reliableness that I need, you know. This is now very interesting. This is very interesting. Okay. Okay. Well, it kinda works now, does it? Yeah, kinda working. So if we do that, we shift here, we do all this, all of that stuff, every millis thing somehow, and then we turn on the pin and we check the buffer state. We check the buffer state every time. Okay, yeah. I'm actually not sure if like this is what we want. Haha, I don't know, man. What do I know? Let's see if our like key works with the keyer now, or if this just still Wait, why would it like work, or like why would it not work? Okay, so if I hold this down, okay, so it works. It's just super weird. Okay, so it does work. Okay, just let me get it straight. It does work, right? If I hold like 2 times, like if I make a da-da-dit, like a, if I do it like, okay, so the da-dit, like it kind of works, you know, it kind of works right now. So the da-dit, right? It does that. So it is definitely like going into the input buffer. It is, or like it gets read correctly by the input, by the buffer reader, and it also gets outputted correctly. So everything of those things works right now. So it's like da-da-dit. Okay, so it does work, right? It does work. It's just that we can only either input or output things. And I mean, I kind of do want to hear. I kind of want to hear it if I, you know, if I do things. Like I want to hear it as I put it in. This is more difficult than I thought it would be. Okay. I see. It is very difficult to think about it now. It really is. I mean, we're like 3 hours in now. Yeah, I mean, we are quite far now. We can input things in the buffer. We can read things from the buffer. We can only do inputting, and then we can only input, and we don't hear the output from the input. And I kind of want to, like, obviously you want to hear what you're inputting as you're inputting it. Yeah. So about that, right? About that. We hear things if we change the buffer state. Now we're doing this thing correctly. This works. This is fine. And it works now. So it's like everything's fine here. Everything is really just fine, and we have nothing to be worried about, except like we do. Cause like we kind of want to hear it as we're inputting it. Now this thing gets executed at like a very the key. This is the keyer speed. This is the keyer speed now, right? So at the keyer speed getting inputted, and Like that is fine. That's fine. Like we're inputting it as indicator speed. We're reading the state. We're reading the input buffer. We are shifting the buffer, and depending if this is the case or that is the case, we're just like we're doing that, right? Right, we're either inputting a DIT or a DAW. We know that works. We heard it, right? So these are the DAWs. Oh yeah, you don't see that. Okay, so here is the keyer, right? So if I do the DAWs, so yeah, basically it only works like sometimes. Like if I hold it down, it just inputs it, and it does not output. Like we do not get any output, like we're not getting here. So we have to be in here all the time. Right, so I mean this works, you know, the thing is it works now. It works quite well. But not like super great. It just works like somewhat okay. Like somewhat okay. That's about the amount of working that it does right now. So yeah, I don't actually know. Like I don't know what the thing is now with this not really really working. It is just that here we have all the inputs. Here we have like here we're inputting and shifting the buffer, and this is the buffer state. And according to the buffer state, like depending on if it's high or low, we turn on the buffer at the buzzer at the frequency, or we are turning it off. Now we're not getting here because we're like probably stuck here. I'm not so sure on how great that is. I don't know. The buffer state, I mean, yeah, we like write the buffer state, and we're here. We write the buffer state again. We're shifting buffer. We're writing to the buffer. Buffer. Everything is fine. You know, that's fine. You know, yeah, it is fine. Except we're not getting to this point. We are not getting to the actual reading of the buffer. I mean, here's the reading part. Like this is the reading part of it. And if we read it, we should be able to do that, right? We should be able to just read it out. Like the buffer state, we have it and we read it. Like if a pin is pressed, we don't read it, you know? Like if a pin is pressed, we don't read it, you know? Which I guess is fine, except like it actually isn't, because like it we read it, right? We inputting things then. Okay, so let's say we have DIT enabled, like, right? DIT is enabled. Now we write to the buffer state what the current buffer is. We shift it, we write it, we shift, we write it, we shift, right? So now we're like 3 spaces ahead, right? or like 2 spaces ahead now, and then like that doesn't happen. We haven't pressed that. Now we get here, we say last millis equals to the current millis, and we do nothing. We go out of here. We should write to the pin, we should write to the buffer state, we write to this thing, and we are going up again. Somehow it does not do that. Right. How, why? I don't know. I mean, I don't know. I don't think it's that great that it doesn't do things. But like, who am I to judge, you know? Who am I to judge right now? Because like, okay, I mean I wrote it, okay? But like, I am now somewhat stuck at this state right now where it does things, and I don't get why it does things, which is a really difficult state to be in. Like I know what it should do. Like it should read the buffer, it should play the buffer, it should shift the buffer, depending on if it's a dit or a da, it should input to the buffer and shift it again. Like we're inputting, shifting, inputting, shifting, and then it should do all of that all over again. Right? But here the buffer state, we should here already like write to the buffer state thing and write this thing. And I mean this thing's, that's only like getting executed three times faster than the interval time here, which is depending on the which is here the keyer speed, right? The keyer speed. This is the keyer speed. And I mean we can do that. And now it looks better. But this is really not great, right? This is not great. It's not good to do that. Now the only thing is that I don't know why the things are happening which are happening. I know the buffer state should be red. It should be red, and like the variable is saved here. Then we shift it. Then we do that. Then we do, or we do that. Right? This is a else if condition here. Like this is not an if. This is else if this one. Then we do that. Otherwise we store the last millis to the current millis, the current millis to the last millis, and we are executing then this code again. This code here we are buzzing at the buzzer frequency, and we're doing everything again. Maybe that already changed things and like made them better. I'm not so sure about that being the case. I would not be so sure if it did that or not. Okay, so apparently it didn't. We should see the LED light up. Oh yeah, this is now very like super like slow. Yeah, I mean, I guess I don't know why it happens. Okay, so we know, like here we didn't do anything wrong. We know this works, we know everything here works. So like this is the code. This is all the code does. It's like okay, and I mean for this one it just does everything just like slower. So yeah, we can collapse that code block as well, and I mean then we have this whole thing as the code, right? Which is not a lot, you know, this is actually not that much code. And yeah, I'm not so sure if that is a good thing here or not. Like the buffer state variable is equal to the input buffer at 0, right? At 0. And that gives us, however, a delay of the whole buffer, right? Because we're, yeah, no, that it does. Oh, I see. This gives us a whole buffer of a delay, which is not great. Like, what if we make the buffer not 16 but like 4? Because like, this is 4. You know what? What if we make it like 4 or 4 here, and then we need to say that's 4 here. Let's make the buffer smaller, and I mean, yeah, last version, last thing is like 3. It's like, yeah, 3, 3, 3, and the 3 again. So now we have basically basically no buffering. Oh no, yeah, no, we just compiled it. What? Why does it note within this loop? Where are you having? Why are you saying we're having fun problems? Oh yeah, no, we know that can happen. Yeah, no, we know that happens. Yep, everything's fine. We have created things to compensate that. This is a warning, and we can ignore it because we already have a solution for that. Why is it doing that now? Oh no, cause it's else if, or right? Or oh no, this is terrible. This is super terrible. This is really terrible. Okay, better now. Okay, so we still have some problems here, and I don't know why. I don't know why. I don't know what the problem is now. So let's make the buffer like 8. You know, let's make it 8. Yeah, so this is really terrible right now. So whatever we changed, it wasn't good. Right, so whatever we did, we did not good. We did not good. Oh, I think this has to be one less than that. So, yeah. I'm just trying to be louder than the actual buzzer itself. It is quite a loud buzzer, and yeah. So we're just going to ignore it right now and up our buffer size to 7, which hopefully is quite responsive and doesn't create lots of problems. Okay, great. So now nothing happens, which is good. Where is it? I'm not that sure. Huh. I mean, if we hold it down, nothing happens, you know? I think now we're just here, but we're not actually, like, we're just in this loop now, somehow, in this loop. And not doing anything else, right? Yeah. I mean, we can just hold it down forever, and it never like writes to the buffer. It just reads, and then it like shifts, and it reads again, and it shifts again, and it reads again, but it never writes. Now, I'm not sure why that is. I'm not so sure. Maybe we set the millers all the way up there. Oh yeah, I didn't change shit. Sorry, language. But like that didn't change anything because, well, we didn't upload it, so obviously it didn't change. Yeah, what I thought would happen. That is insane. That's actually insane. Yeah, no. I think 4 was already fine. It's just that yeah, we have some bigger problems now. With all of these things. And yeah, somehow it has to do something with the reading and the writing to the buzzer, you know. So we're reading it, we're writing to the buffer, and somehow that just in a loop, and we're never out of this thing. Yet we are. Buffer state is just this one. So like we can read from a buffer very slowly, but we can write to it very quickly. Which maybe that is a problem. Maybe it is. You know, maybe it actually is a problem. Maybe we should take all of that code and like create a separate loop for that, you know. Maybe we should have a second thing here, happening here, which just does that. It just is there, and yeah, it's basically a second way, like a reader, right? So like we have the writing loop and then we have the reading loop. But I don't know where this would make sense in that particular thing. I mean, yeah, maybe it doesn't make sense. Maybe it does make sense. I'm not so sure. But what I do know, and what I hope that happens now, is that it just works like I'm expecting it to work. We're not using that much flash or RAM at all. I mean, 32 bytes of RAM, like under 1.5 kilobytes of flash, that is nothing. Especially for this IC. I'm using the ATtiny 3224 chip, which has 32 kilobytes of RAM. which flash, sorry, flash, 32 kilobytes of flash, right? You can see it right here. And yeah, I mean it just works. Uploading works, everything works except for that. Yeah. Oh no, now it's working like less than it was before. So that's not something that's great. So it worked like better before, even though it didn't work all that great, did it? Yeah, and now we have here the separate like reader from the writer separate. Yeah, I'm not so sure. Maybe I should like what? Maybe I should like make this like twice as slow, cause the first thing that we're doing is like at least 2 times, like 2 times writing at least. So maybe that helps. Maybe I'm not so sure. I mean, another interval, right? Last mill is 2, last mill is 2. Yeah, I mean, we just have lots of functions now. It's not that yeah, the code is just not that like great, I think. I mean, it's great, but there are a lot of variables, and knowing what the code does now is already quite difficult. Like it really is difficult, and yeah, I'm not so sure if I should like. I mean, I'm just gonna copy paste this and well say that this is last mill is 2, and haha, problems fixed. Hopefully, we're hoping for the best. We are hoping for the best. We are creating a Morse code keyer right now with the itty tiny 3224 chip, and I'm just like I'm creating this from like 0, like at the beginning of the stream we didn't really have anything, not even the circuit, and I mean now we do have something. We do have something now. This is, yeah, that works way better than expected. I have to put this in the camera view. Okay, so now we're doing again weird things, very weird things. I mean, this would be the da, so this would be da 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 da. This is what this button should do. I mean, it kinda does it, kinda. I'm really confused. I'm really confused because it like doesn't. So somehow yeah, okay, so this is not the best thing. It's, I mean, I think this is better now. I feel like it's better. I feel like it really is better. Like now it really feels way more responsive than it was before. It just doesn't feel too responsive now. So okay. So the thing is, we do have a buffer. We do have like that set up correctly. It is already quite responsive. it already is quite responsive. Now, maybe I should do a like different like interval time times 2 or times 4 depending on if we have the dit or the da. Maybe that will improve the quality of this product, or like more like prototype. Like hopefully this improves the quality of this prototype like a ton, right? Like very much. We have like lots of variables. It's like not that not best kind of thing, but we have things now that like it works. Let's like just look at this. Like if we press the dit, it does the dits, and then it does like weird things in between. I don't get why it does like those weird things in between. I don't get why it does it. If anyone knows why, can write it in the chat and like help me or something with that maybe. Yeah, so it does weird things right now, and yeah, hopefully everything works by the end of this stream, or hopefully at least by the next, or the next stream, hopefully. I mean, this is a little challenge that I have done for myself, and I've just noticed it is obviously, as most of my projects are, way more difficult than it seems to be in the beginning, right? So honestly, I don't think we should have a last millis 2. I don't think this is a great thing to have. I think this should be depending on last millis. I think this should be depending on last millis. I'm saying it, okay? This should be depending on last millis. Then it does that, then it does that, and yeah, I think it should be. But then last millis should be updated here in this code, and last millis 2 is just like not used anymore, and that should improve the quality, right? Okay, so we're uploading it again. Yeah, we still have like basically nothing. Okay, never mind. Well, it doesn't do anything now, so it does not do anything at all. So we are just going to get back to that thing. Like that was already quite well. That was quite well. That worked quite okay. I mean, it wasn't the best, but it worked quite well. Now this is interval underscore multiplier. So this is the interval multiplier, which if it's that, input multiplier would be 2, right? And if it's the what? But then if it's the DA, input multiplier would be 4. Now input multiplier is here an integer, and it's that thing, and it's like 2 by default. And now we're uploading it again and seeing if it works, and hopefully it does. Honestly, hopefully it does work. Yeah, we will see honestly. I mean, yeah, it's just uploaded. Okay. This is weird. Okay, well, that's interesting, at least. That's interesting. It really is, okay? Now, we don't have that much space. I'm just gonna have this as a byte, which would be the buffer size. I think we I think we need to increase the buffer size, and yeah, I hope that that helps definitely with whatever we are wanting to achieve. I think 32 is a good buffer size now. I'm using that variable to be used in every single piece of like code right here as well, and like that hopefully speeds up the developing process. And yeah, I mean, I don't have to change the buffer size like 16 times in the code, just have to declare it one time on the top of the code, and that's gonna be fine. And then that's it, you know, that's it. That's how it works. Buffer size. Ah. What must have a constant value? The value of variable buffer size declared at line 18 cannot be used as a constant. Yes it can. Yes it can. Now it is. Now it is a constant byte. A constant byte of 32. Okay, that's the buffer size now. And that may or may not help. I honestly have no idea anymore. No idea. If that works or not, we will see. We will see. Huh. I'm pretty sure this didn't help at all. However, we can change it easier now, so it kinda helped, like, okay. Going down to a smaller buffer size is hopefully going to help with latency problems that we're having right now at the moment. I mean, Yeah, that's not good. That is not good at all. Absolutely not good at all. Like, not at the slightest. And yeah, so that's great. Yeah, I love that. Trial and error till it works. Yeah, this is very weird. This is very weird. Yeah, this is really weird, okay? Yeah, I don't like it, okay? I don't like it. Simply said, I don't like it at all. However, do I think the multiplier helped? Yes, I think the interval multiplier helped. I think it did. I think it did help, yes. However, do I also think that it is kinda weird and it's just not doing that great, and like some things sound weird and I don't know why, and it's insane and I have no clue, or do I have a clue? Okay, that's... well, that is weird. And that's all I can say. It is really weird. And I myself don't know why that is. I'm not so sure why that is the case. And yeah, the thing is, I yeah, no. I mean, it should work, you know, that's the thing. Did Okay, smaller buffer, more hope, and hopefully working. If anyone knows how to fix this, please write it in the comments down below or in the livestream chat right now. Right. So. Okay, I mean, that's just doing weird things at that point. Yep. Weird things, as I said. Weird things. very, very weird things are happening right now. Very weird things. Do I know why? I'm not so sure why it would work or why it wouldn't right now. I mean, the buffer situation definitely works. It's just that, like, things don't quite work with the buffer, right? Right. That's about what happens. Yeah. I mean, if I did do it like the dits, work. The does, I'm not too sure. The does do like weird things is what they're doing. Weird things is what they are doing. That's how you say it. It's weird things. Weird things. Yeah. Does don't work. The dits work fine. You know, the dits work fine. They do work fine. They're twice as slow as the interval. So I mean, the multipliers it's set to 2, and that's by default, and that is working fine. I'm also not so sure if that's what helps. Yeah, the thing. Yeah, no, this is fine. This is interesting. It's surely an interesting thing to do. I mean, yeah, no, I have totally an idea what's happening here. Totally. I mean, like, definitely this is great and everything works fine. Yet it still doesn't, and it's very frustrating. Yeah. But we wait for the next time so long. But like that's fine, cause this takes 4 times as long to be done. So this has priority over this thing. Or does it actually? I mean, actually, it like the writing is done before the reading, but like that's irrelevant, right? It really is just irrelevant, and it should all work fine, and everything's great, and everything is fine, and things like that, right? But yeah, that like it shouldn't not work now. I mean, yeah, huh? Is this? No, this is weird. Yeah, something tells me that this is not the way that you should do that. I'm not so particularly sure if this is how it's supposed to work, or like how I wrote it, how this should work. I mean, it just be a simple Morse code here. I guess it's not that simple after all, and it's really difficult to like have a good Morse code keyer, especially on a like such a tiny chip which only has like 32 kilobyte of RAM. of flash, right? 32 kilobytes of RAM, 3 kilobyte of, yeah, say it again, 32 kilobyte of flash and 3 kilobyte of RAM. And I'm planning to go down to like 8 kilobytes of flash and like even less RAM. So like writing code for such tiny chips with that very limited space is really difficult, and you really have to know like what the limitations of these chips are. Oh, this is fast. Okay, so I mean this works now. This works quite well, honestly. Hold on. So the interval time here basically dictates how long this takes and how long everything basically takes, except for like this, because this is the very fast, like this is like a rapid fire PWM ish thing. It's basically like the tone library, except it's not, and it's somehow better and working better than the tone library with the tiny. No idea why that is, but that's how it works. We can change the pitch of it here with the frequency. The frequency is getting calculated in the setup, and that's working quite fun. We can change the frequency, everything's fine. Now, interval timer, right? I've just heard that it does work quite well, but maybe we just have to like down the interval timer to like make it the interval time like very small, but like not that small, not like 50 small, but like maybe 100 or like maybe 80, maybe 75, something around those lines. I mean, that it takes. It. Okay, this is a super interesting yet not that perfect thing. It's already quite well. It does already quite well. It's just that it seems not to sound right. Like something is wrong. Something is clearly wrong, right? And I can't put my head around it. I don't know. I have no idea what's the like. It feels okay. So now it feels already quite good, yet I can, like something feels off. Something feels off, and I'm not so sure what that something is. Okay, so M would be dada. O is da da da. This, yeah, that's what I mean. Something sounds off, and like that's definitely not how it should sound. It should sound da 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 every time. It doesn't. Why? I don't know. I have no idea why. And it's quite weird because it just does that, and I don't get it. I don't. Maybe last minute is here as well. Like maybe, yeah, we've already tried it and it didn't work. Maybe it does this time. Yeah, no. Probably won't work this time. You know why would it work this time? Like, like don't be silly. Yeah, but like, it's weird. This is super weird. Like, really weird. I don't know how this works. Okay, so yeah, well, this is very difficult. It's not simple at all. I mean, I thought this was like super simple and is super easy to do, yet it is not. I don't get it. Like, if you hear this. Like, it just sounds off. I can't put my head around why it sounds off. I just know that it sounds off. I don't know why. I don't know why it sounds off. Like, probably like something is overflowing and like not doing the right things. That's for sure. But why? I don't know. I don't know, man. I don't know why. Like, could be lots of reasons why. Yeah. That sounds great. And I mean, increasing the buffer size increases also the delay between pushing the button and actually hearing it, because I'm inputting the things on the last index of the array and I'm reading at the first index of the array, right? So the longer the array is, the longer it takes for like the signal to actually be there. So yeah, I mean, if I do like a 64 array, you're not gonna, like, this wouldn't be great. Maybe 8 would be actually the best. Like, anything under 4 wouldn't work because like we have all of these things. Like, those are already 4 things, and yeah. Maybe a little more than 4 is great. Maybe like anything over 6 is bad. Maybe everything over 10 is bad. Maybe everything over 16 is bad. I'm not sure, and I need to try that out. And basically that's what I'm doing right now. I've already uploaded it. Uploading here with the Entertiny is very fast, like 7.5 seconds, like not even 10 seconds for uploading. Insane. Hear that? I don't get what it is. Yeah, this is not great at all. This is not great at all. Yeah, things are not going the best. Are not really going the way that I expect them to go right now. And yeah, that's not great. So, okay. So we know that the issue has to be somewhere here. Like, we know this works. We know that part of the code works. It's like, we can eliminate this code. We can eliminate this part of the code because that also works. So now we only have this thing left. And here the only problem is probably gonna be here with this thing, with this thing, or something to do with the buffer system. It has to be one of those things that are like wrong. Maybe I'm going to create a dit buffer and a da buffer, like separate buffers for those as well, with some separate buffer counters, and yeah, I'm hoping it works. Maybe I'm also not inputting at the last state, but at the current state plus 1. But then again, I would have to count with that, and I mean, in the end, it's probably just gonna be at the last index of the of the array, anyways. That might help, but yeah. I mean, that's basically wrapping it up for today. So yeah, I mean, basically what I can say is that currently we are at a state where it kinda works, and it just has like a few problems with it that need to be fixed, but I'm gonna do that in another stream. I mean, if you don't want to miss any of my streams, make sure to like, share and subscribe, and well, I will see you then, and have a great time. Bye!